Deep learning is everywhere, and it's specifically true for you because you've been at the summer school and you see so many examples of deep learning throughout this week. It is also specifically true for me that I'm working at Mila. So there are so many applications based on deep learning that you can see nowadays. This technology is very successful. It actually changed many fields, specifically computer vision. And if you search deep learning in Google, you can see many examples of applications of different applications that people are actually using it. So they're using it for science, discover new things in physics, for instance. In finance, they are actually using deep learning, and it actually influences on people's life, improving people's life. And there are some studies nowadays on how we can use deep learnings to save our planet Earth by just using in agriculture, in climate change, and et cetera, et cetera. So it's a very successful technology. But it's not just that. So it also has an ugly face, not just deep learning, but machine learning in general. It also creates some problems. So it actually influences on people's life negatively. So I'm not sure if you see some of these examples already, but so for example, there is this one for the policing that it shows that polices stop cars when there is a black driver driving the car more than white people, or even going to investigate in the areas that black people are living. This study is about the Amazon. They had this recommender system for jobs, and they recommend highly paid jobs to men more than women. Or this face recognition. As I said, computer vision actually changed by deep learning, and it actually detects faces very well, but it actually worked very well for white men. If you are looking at black women, for instance, it's not working very well. So this study by Joy Bulanwini and Timnit Gebru, they showed that it's actually not working for black women, and Joy actually had to put a white mask in front of the camera for her face to be detected. So this was really bad, right? So it's actually influence on people's life. Or this study on the criminal risk. So this ProPublica, it went viral because in the US, they actually used a system called Compass to get the score for the criminals. And then if there is a higher score for the criminal, they will go back to the jail. So this system was really biased toward black people. So many black people, without any differences between the white people, they get higher scores, so they actually put back to the jail. But is there any solution? So can we say that these machine learning techniques are just techniques, they are innocent? So because companies are using these techniques to improve people's life, we should not blame them. Can we do anything about discrimination? Because most of the people saying that this discrimination that we are seeing for machine learning is actually coming from a data that we are using. So it's from the human judgment. So they are not really, this fact is not untrue. So machine learning techniques, in fact, are actually using the data. They're learning these patterns and behavior of discrimination from data, and they can actually mimic it. So if we have a stereotypes, discrimination towards some population, machine learning can mimic this behavior. Let me give you some example. So this is a hypothetical extreme example, right? So assuming that there is a bank wants to give a loan to people, and 90% of the population are raised and born in Canada, meaning that we have all the information about them. But there are 10% of the population that we have in our data are immigrants. This is extreme hypothetical situation, of course. And we don't have much information about this population. If you are making a system which is actually working 95% accurate, is it good? Is it 90% accurate for overall? So people are actually deploying such system if they are calculating the performance of the system and see that it's actually 90% accurate, so it's a good system, so we can deploy it. But if you're looking at this population, you see that it's actually 95% accurate for the Canadian and 50% is actually random. So it's actually working randomly for immigrants. So this is a problem. Why this is a problem and why we should take care of fairness? Of course, it's not ethical. It's against human values. But more importantly, we should address the law against discrimination. So the list that you're seeing here is based on the US, but I'm kind of sure that's actually the same thing in Canada. So there are some regulated domains. So in terms of, for example, giving credits, housing, education, healthcare, you cannot discriminate against this population. They call it protected class. So you cannot discriminate against race, gender, age, etc., etc. So it's important that we know that why we should care about fairness. The most important part is that we have to address the law against discrimination. But fairness in ML is the way that we wanted to address this problem. When we have the examples that I showed you before, what we can do. But it's a new topic. So up to 2014, people were not really thinking about fairness in machine learning. There was a report during Obama's presidency called the 90-day review for big data, and they actually addressed this problem. So they wanted to just increase the awareness about we could have discrimination. In 2015, there were papers about policing, there are discrimination against Black people. 2016, we had ProPublica, and then 2017, the study by Joy Buolamwini. They call it gender shades. And this is the picture that Crawford showed during NeurIPS 2017. So we don't have the information from 2017 up to now, but there are so many works studying discrimination and fairness in machine learning. But it's not a new topic. So this fairness in automated system and the problems that we could have, people are studying in education, in hiring, and this is a study by Margaret Mitchell. It shows that the terms that we are using for fairness in machine learning, people actually studied the same thing in education 50 years ago. And it's not just education, so in statistics, social science, people are actually talking about it. It is new in machine learning though. Why it is important is that in decision making, it was always important to talk about fairness, but when we are talking about machine learning, the automated system, it is more important because we could have a systematic bias. A systematic bias is that we cannot do anything about it. So if you are getting this outcome of the system that is discriminating you to not getting this, for example, loan, you cannot do anything about it. And if it's getting systematic, if you are, for example, female, Black, you are not getting the positive outcome that you are looking for, whatever you're doing. So how we can address it? In machine learning, the process, this is a simplified version of the process that we have. So we have data, we have a system, and we have the outcome. The data, and we can have bias throughout the system. So we can have a bias in data. So we could have noisy data, discrimination, stereotypes that is actually in data. We could have in-processing biases. So data scientists who are not really familiar how to use a tool, they are actually using the tool. And there are biases coming from the negative, without having the knowledge, they're using it and it's not really working according to what it should work. So there are some biases there, and there are some post-processing biases. So we are getting the outcome of the system, and they are making decision based on it. And it could also have some biases there because we don't have, for example, a human in the loop to give us feedback, and etc., etc. So people are working on pre-processing fairness, in-processing fairness, and post-processing fairness. There are different techniques. So I will talk about briefly on these topics throughout this talk. So on pre-processing, how we can actually unbiased data, clear the data. In processing, if we have this machine learning technique, how we can actually make it fair. And for the post-processing, how we can explain the results and how we can make a decision based on it. I will also talk about the verification, which is a bit different than all these three topics. The verification is that when we have a system, we want to give guarantee that is, for example, fair or not. But how we can actually do it? The first thing that we need to define is a metric, fairness metric. So how we can define something is fair. And why we need fairness metric is that we need this metric to actually support these human values, right? And we have to identify the weakness and the strength of the system. having this measure, we can actually track the progress of the system through like in time, but also, as I said, to address the law against discrimination. In machine learning, I'm not sure if you heard already in the conferences, we have more than 21 different definitions of fairness already. So if you are interested, I will encourage you to actually look at this tutorial by Arvind Narayanan, and he's actually explaining different definitions of fairness. And also, there is another interesting talk by John Kleinberg about the definition of fairness. So the differences why we have this definition over the other definition. In this talk, I will also discuss some of the definitions which are very well known, but I'm not covering the whole 21 definitions of fairness because of time. Also, these 21 definitions are in this paper by Verma, and he actually have one example and showed like what's the differences between this definition if you have one running example. But what you should remember is that these definitions are different. So simple thing is equity and equality. They are fairness measures, but the outcome of them are very, very different. So why we don't have one definition? One definition can actually work for any scenario. The thing is that the fairness is subjective. It's not a general concept. So although I mentioned that there are some legalized domains, for hiring, if we are discriminating against gender, that's a problem. But for healthcare, if the case is, for example, the medical diagnosis, some diseases are just for male and some diseases are just for female. How we can actually make it fair and using one definition of fairness that, for example, the population should be the same? It's not going to work. So for each application, each domain, we have to come up with a new definition. And one of the reasons that we have many definitions is that to actually cover all aspects. But I will show you one example here. The thing is that Kate Crawford, during her presentation, showed that if you are searching for CEO in Google image, you only see male CEOs. If you search now, they actually fixed it. So if you search for CEO, do you actually see some pictures of the women CEO? But I search powerful CEO. Still, I'm getting the same problem. So apparently, they just fixed for that particular term, which is CEO, and not powerful CEO. But I'm just asking you, if you want to actually fix it, how we should fix it? Should we fix it based on a population? Like because we have 50% women, 50% men, should we show 50% of the image of men and 50% picture of the women? Should we show based on the population of the CEOs? For example, in the US, we have 11% female. Should we show it based on that? Or, because we know that there is discrimination happening at the moment, should we actually fix it? Show a bit more, like 20% female, to change the image in society? So if I ask you guys to actually judge, we may not agree on one way of showing this result. So you can see the complexity of coming up with one definition of fairness here.